That's to find the area of a triangle given just its three corners. So what I did is I started off by drawing those three corners. It took me a little bit of time, so I didn't show you the whole process. But I named all three of the points, P, Q, and R. At first I didn't have the points named, but just so I could have nice names for them down here. And so, for other reasons, I decided to give names P, Q, and R. So you can see that this point P, see, he's off in the negative second direction, so this what you would probably call the y direction. A little bit negative over there. With that -1 right there. So he's to the left of Q, despite the looks of things, right? The looks, maybe, I mean, if you kind of interpret it too literally, it looks like Q is to the left of P, but that's only because of the perspective that we have relative to this coordinate system. Certainly P has the smaller second coordinate. So at any rate, these three things, these 3 points certainly define some kind of triangle, and perhaps I could draw that triangle in blue. The green's not showing up real well, but so the experiment goes. The triangle, of course, go from here to here in blue, and there to there in blue, and there to there in blue. And, you know, a little bit of wiggliness there because I'm nervous on the camera. But that certainly looks like a little bit of a triangle. You know, I think maybe I'm wrong. Isn't the length of a cross product the area of a parallelogram formed by the two vectors? Right, so I should say not that the area of the triangle with these corners is the length of this cross product of the vector formed by QP and the vector formed by QR, this red guy, and this green guy that's not showing up very well, at least not on my screen. It's half that, isn't it? Let me find that black pen. Is half of the length of this thing. Okay, so continuing with that sentence, what is this vector? We're going to find the vector and then find the length. So I've been encouraging you, well, implicitly I've been encouraging you to think this way, but let me say explicitly, it would be very nice if you didn't have to go off in the corner and make a I hat, J hat, K hat, -1, -1, 1, -2, 2, 0 every time you did this, right? It'd be nice if you could just quickly read through these things. Let me assure you that these products, these cross products, will come up again in many other places. You'll be working with cross products extensively in 21D if you're going there. It also comes up in physics and engineering and even computer science quite a bit. Oh, and certainly chemistry. Let me forget that one. So what I'm going to try to do again is to compute this cross product just looking at the component form. The first component of this will be what I get from ignoring the first component of both these guys and taking -1 times 0, oh, that I can do in my head, minus 2 times 1, so that's a -2. The second component I get by ignoring the second component of these guys and putting an additional negative sign. So let me think of the additional negative sign. -1 times 0, oh, well, that's easy, minus -2 times 1. Minus -2 times 1 is 2. And what else? Yeah, the third component I get from ignoring the third component of both these guys, that'll be -1 times 2, or -2, minus -2 times -1. Ah, it's 3 negatives. So, yeah, -2. Okay, good. So that will be -2, -2, -4. Let's think about this for a second. Do I expect that? The magnitude of this guy is pretty big, and the magnitude of PQ is also pretty big, so this guy's got an even bigger magnitude than either of them. That seems about right. And as far as the direction, negative in all components. So let's see, the green guy crossed with the red guy, so go point in the green, second in the direction of the red, perpendicular to that, my thumb over here, is pointing entirely down and towards me. Right, so that direction seems good too. So now that I have the vector here, that is the cross product, I'm trying to look for half of its length. So its length would give me the area of a parallelogram, and half of that would be this triangle. So I'll say comma, or 1/2 the square root of 2 squared. 2 squared plus -2 squared plus -4 squared, and I will simplify that to 1/2 4 plus 4 plus 16, and that is 1/2 the square root of 24. And I could factor 4 out of that 12, and let's see, 4, so half of 24 is 12, half of that is 6, so that'll be a square root of 6. I factored out the 2, and that 2 will cancel with the 1/2, and well, that's it, square root of 6. You know what I can do?